Hi guys. Today we're moving on to section 6-2. In our first video, we'll focus on that first word, which is multiplying rational expressions. And in our second video, we'll focus on the second word, which is dividing rational expressions. Let's get started with multiplying. So underneath the video, it says combining radical expressions, products. Product is like the fancy math word for multiplication. So it's just a fancy way of saying, hey, let's multiply some radicals together. All right, so here's a generic example. We like to use A's and B's, and then we like to use the letter N for our index on our generic example. And this basically says if two radicals have the same index, so notice that they're both the letter N for the index, then you can combine them together into the same radical using the multiplication. So by multiplying two radicals with the same index, I can make it one radical. I just got to multiply them together. Please notice that the index itself does not change and that the numbers inside are being multiplied. So I don't change my index. It's got to stay the same type of radical. And it was a multiplication problem. It's going to stay a multiplication problem. Please take a minute and pause the video and try these problems on your own. Numbers 1, 2, and 3 are true or false. So you just got to figure out, is it right or wrong? And then numbers 4 and 5 want you to actually simplify. All right, let's check and see how you did. So on number 1, I hope that you got false. Number 2 is true. And number 3 is also true. Well, let's focus on number 1. Number 1 is false because even though I multiplied my 4 times my 6 and got 24, and even though they both have the same index of 3, the mistake that we made was we actually changed the index to a 6. I added 3 plus 3 and got 6 over here. And so that's why number 1 is false. It's because my index changed and it wasn't supposed to. If this had been a 3 over here as well, then we would have been all good. Number 2 is kind of working backwards, and you're totally allowed to do that. You can take a radical and split it into two separate radicals if you want to. But really, if we're looking at this from right to left, then we have 2 cube roots, and then 4 times 9 is 36, and this one stayed a cube root, so we're good there. And then number 3 also, 3 times 8 is 24, and these were both fourth roots, and it stayed a fourth root, so we're good. With that in mind, let's take a look at numbers 4 and 5. Number 4 says simplify, but I can't simplify. That's not possible. So you can write not possible, or you could write in simplest form. So when it says like simplify, you say, nope, it's already simplified. But number 4 is not possible because the indexes are different. One's a fourth root and one's a fifth root. Now, number 5, those are both fifth roots. So I can multiply them together and I get the fifth root of 10. These were all pretty straightforward, pretty simple. There's not even any variables, which is an algebra concept, right? So let's take a look at one with a variable. All right, so in this problem, I have 2 square roots. It's important that they're both square roots, and they're being multiplied. And so I'm going to combine them together into a single square root using that multiplication operation. Now, here's something to just help you out a little bit. When you're combining them into the same radical, do not multiply the numbers together because your next step is going to be to factor tree. And I would much rather factor tree 45 and 35 than whatever 45 times 35 is. Like, that's a huge number. And your first step is probably going to be like, let's split it into 45 and 35 again. So don't actually multiply. Just write down like, hey, I'm going to multiply. All right. For your numbers, again, your first step is to factor tree. So you're going to factor tree the 45 down to its prime numbers. You'll factor tree the 35 down to its prime numbers. And since they're all under the radical, you can just put them all in one long list. For your variables, it would be okay to combine those together into a single variable. Remember, our rules for exponents say that we add the exponents together. My 45 turned into 335. My 35 turned into 57. And we just make that one big long list. For my x's, I now have x to the 6th. And for my y's, I now have y to the 7th. According to yesterday's videos, since this is a square root, I will be looking for pairs of numbers. I have a pair of 3s and a pair of 5s. The 7 doesn't have a pair. For my variables, I can take the exponent and I can divide by my index. Now remember, there's an invisible index of 2, so I will be dividing those by 2. 6 divided by 2 is 3. 7 divided by 2 is also 3, but it has a remainder of 1. And that remainder of 1 will remain inside the radical. So on the outside, I have a 3 times 5, also known as 15. I have an x to the 3rd and a y to the 3rd. On the inside, I have a 7 and my remaining one letter y. Please notice the space between the y to the 3rd and the radical symbol so that I can very clearly see this exponent belongs to the letter y. It is not an index on the radical. Here are a couple for you to try on your own. Feel free to pause the video and then we'll check our answers. Let's see how you did. Now, number 1 is not even a multiplying problem. It's just straight up simplify. That's actually from yesterday's video. And for that problem, I got 2x, and then notice the space, and then the cube root of 4x. So we want to leave a little bit of space in between so that it's very clear that the 3 is an index on the radical, and it is not x to the 3rd. Now, that second one is from today, so make sure that you've tried that second one. And here is my answer for the second one. So I got 12x squared y squared, then I left some space, and then I have the square root of 5y. This concludes our first video for today.